So we're going to chat about what we're going to do next about a latency spike we're seeing on Redis related to the cache evictions when we reach max memory. Yeah, I don't think we need to repeat all of the context that we discussed yesterday, but now we're going to, like we've done several investigations on the Redis side and on the application side, and we're going to see where we're going to take it from here. Yeah, Matt, you were saying before I interrupted you?
Yeah, no, it's all good. So at this point, we've established that the Redis latency spikes, which are triggered by the eviction bursts, are driven by the eviction mechanism reducing Redis client throughput enough that we have a backlog accumulate quickly, which competes for memory, which drives the eviction cycle. And this only abates approximately when enough clients get stalled that the incoming request rate falls low enough that that evictions can keep up. So that's how the cycle ends.
And that's like the conclusion that we take from
Yes.
that is that we, for this type of Redis instance, we need to be below max memory.
Yes.
Or we need to fix the way that Redis evicts at max memory.
Yes.
That's kind of the two options we have.
Yes, exactly. So yesterday we talked about some potential changes to. So I kind of want to focus mostly on what we can do for the sake of our own system, which as we discussed yesterday is chiefly the presumably simplest thing we can do is reduce the TTLs so that our demand for essentially for the word key space has a different connotation in the context of Redis. So let me come up with a different word for it. The demand for how much memory we need to store our keys needs to be less than max memory. And the main control we have over that is TTL. The secondary control we have over that is what Redis instance do we store these keys in, which leads us directly to the repartitioning discussion.
Yeah. I think for reducing TTLs, I think we need to, because I was looking at it briefly, there's some keys there that really stand out that shouldn't, like there was one key that was really low hanging fruit that took almost 2 gigs of memory by saving something for half an hour, and we only need it for a few minutes really. So like, that's like low hanging fruit. I think we should find them and fix them.
Yes.
That seems like something that should be done regardless of this situation.
Yes.
Agreed.
But not all of them are easy. Like it's not always easy to track down where a key is coming from. So
I'm guessing asking the stupid newbie question, which I will be able to use for at least another month or two. I'm guessing there's no super easy split in this data, right? It's mostly all cache data, and there's not like, this is a cache for one thing that we could very easily move somewhere else.
That's the exact question I think we should explore next. Is how should we do? Well, all right. So next, so reducing TTL is probably the easiest thing we can do, and the goal there would be to reduce the demand for storage space. That's what I'll call it. Key storage.
When you say reduce TTL, that's one of my questions that I had. Do you mean reducing the default TTL? Like right now, that's set to 2 weeks, which we never meet. Like we never have it.
No, this would totally be driven by your analysis of the. So, do you have handy the table you were sharing yesterday?
Yes.
And I guess my second question on that table, which I read a lot about this last night. Have you done the analysis for less than days? Meaning that table is all days. Do you have it by hours?
No, I meant to do that today, but I didn't get to it yet. So no, I still need to do that. It takes about, I think about 45 minutes to run on my machine, so we're not going to watch that, but I'll do it first thing on Monday. Let me share my screen to go to the table.
Because I think that's going to be the only thing, like, at this point, looking at that TTL thing, it doesn't make like everything's less than a day. So everything's used within a day. So that doesn't really tell you
everything
anything
is
useful
evicted
yet.
within a day is what we're
Correct.
Yes. So here's, am I sharing my screen? Yes. So here's the table. I mean, again, make this a little bit bigger. Yeah, I haven't figured out how to screen share a single window. So like it just completely breaks Zoom and then
Okay.
reboot. So that's
no
why.
worries. Yeah.
So here's the list of big things. These two we
Yes.
can ignore because that's the entire key space.
Hang on. So this is large in terms of. Let me just clarify the units here. This is
Bytes.
byte count. Okay.
Yes.
Not count of keys. It's a count of bytes. Okay.
Count of bytes, which is what we're interested in.
One of the two things we're interested in. Actually, maybe this is a good time to just to talk about. So there are two aspects of this, and I think we can kind of approach from ideally both directions. And we've talked about this before. I just want to kind of bring it to the forefront since this is germane to the current topic. The pressure comes from how many bytes of memory we're using, which is why it's relevant. The eviction mechanism doesn't care a fig about the size of the keys that it's evicting. It's completely unaware of that when selecting keys, and so when we classify keys, the classes of keys with the largest count are the ones that are most likely to be evicted. So for purposes of the evictor, key size doesn't matter as much as however we categorize the keys, which category has the largest count. But in terms of avoiding evictions entirely by reducing our demand for key storage space, size does matter. So those are the kind of two angles I wanted to kind of try to keep in mind at the same time. So with that preamble out of the way, let's go for it, Bob.
Yeah, so what do these two we can ignore. That's the entire, everything we store under these bits of keys. Some context, this is done with the tool that Jakob built last year for Redis analysis. So I'm not going to go into exactly, but it tries
I found
to
that
match,
link.
Yeah, it tries to match keys according to the prefix, and then it will try to match them to something that it already knows. So that's why these two are separate and are very big, because they basically contain everything that we see below here. This one is also not very interesting because that word is the prefix of project, which we'll see later several times. So yeah, this one I've already taken care of. That was the low-hanging fruit. And then there's some things, that are just big by... one thing also to note, this is already compressed. So the data stored inside the key is already compressed. Right. And then we need to go through all of these. Most of these go through rails.cache, which means that we don't have super a lot of influence over how they're accessed and how they're stored. For example, the things that include view here, for example, those are serialized partials, often serialized partials. Yeah. So plain HTML, so Rails doesn't need to render them again.
And just a refresher, I remember Kwong-Min was working on compression for Sidekick jobs, but I don't remember the rules for and for that one we have a threshold where the job definition has to the
1 kilobyte.
Exactly. Do we have such a threshold mechanism in place here, or
I don't know the threshold for Sidekick, but the default one for Rails I looked up before this, and that's 1 kilobyte. So everything bigger than 1 kilobyte will compress.
Okay, fantastic, thanks. And that's client-side compression.
Client-side compression, yes.
Okay, great.
I don't know exactly which level of compression though. I haven't checked that, what the default of that is.
Okay.
Yeah. So what you're suggesting, Matt, is to go through all of these, figure them out, and see if they have an appropriate time to live set. Most of these are going to have the 2-week default, I think.
Gotcha. Okay. Yes. Yes, that seemed like it was the simplest thing to do. And then for if it's convenient, we can also perhaps classify them by whether or not it would be feasible to move them to a separate instance. And I think, as you were describing a moment ago, going through the Rails default caching mechanism makes that harder. So.
What I think might be interesting is to perhaps go through all of the uses of multiple keys, the multi-key commands, and moving those to a separate instance. Because then what we've got left is something that could fit on a Redis cluster instance. That's going to be the most part of, like, the biggest part of it. But I don't know if that's worth doing space-wise. So
yeah, like it's definitely worth doing for the long-term goal of getting to Redis cluster. And I guess we have to do that analysis to find out how much of the storage space we're talking about to kind of assess whether that's a now thing or a near future thing.
You mean if Redis cluster is a now thing or a future thing?
Oh, sorry. So moving the so if for example we find that I'm making these numbers up totally. If we find that what are we calling them? These are multiple Redis commands in a single transaction, which doesn't play well with Redis cluster.
Cross-slot commands, we called them.
Thank you, cross-slot commands. Yes, I was spacing out on the vocabulary term. Yes, so if we end up having say 10% of our key storage space being used for the cross-slot command keys, then moving that 10% of the key storage space out of the existing Redis cluster may reduce it by enough to avoid the saturating max memory. And if it doesn't, then we still have more work to do. So I guess I'm kind of thinking that a relatively small percentage of the as far as I know, I thought that we have been avoiding the cross-slot design pattern. Is that?
We have like safeguards in place.
Yeah, but we have to tag them with explicit hash. Yeah.
Like right now you can't do specs will fail if you try to introduce a multi-transaction thing that wouldn't fit. But everything that was violating, we've just tagged with, and then don't raise.
Okay, gotcha. So we've so it sounds like then we know the areas that have the tech debt of needing to be tagged so that they can be compatible with Redis cluster.
Yeah.
Okay, fantastic.
Okay, so I'm going to write some things down.
I've been trying to take a couple of notes on things that you've mentioned as next steps, by the way, because I figure that is at least a useful thing I can do in this conversation.
Awesome. Thank you. I mean, your third set of eyes is super useful. I love the questions you're asking too.
Speaking, by the way, since Bob just switched over to this, as far as Redis patches go, does it I think that is a really much longer term potential solution, but it doesn't seem like Redis has any ability to evict based on key size, does it?
That's true. It's got a set of policies, and none of those policies are sensitive to key size.
It seems like that would be the Redis. If I was going to go make something for Redis upstream, that's the one I would probably look at, because that seems like the thing that would be the most useful to more people in the world and would still potentially fix our problem.
Yes.
Go ahead.
If I understood what Matt explained yesterday correctly, then it will look at idle time and time to live for expiry. But it sounds like it would be very useful if it would pick the biggest keys of those.
I mean, if I had to go to the level of Redis patching, of all the things that you could do, and there was a lot of discussion about making lazy evictions and max memory and etc. The one I think would be the most useful to everyone would be take the biggest ones out first.
These are super interesting topics, and since this is a short meeting, I'm kind of resisting the temptation to get into the details.
We don't have to get into the details. I'm just adding it as a thought for the future.
It's a good idea. Let me just briefly then add that eviction is kind of a last ditch saving throw.
Absolutely.
And the Redis, so from a design perspective, Redis expects to have numerous keys, and it doesn't. I guess what I'm working up to is when it gets to the point of having to do evictions, Redis doesn't even attempt to say I'm going to evict the key with the shortest remaining time to live. It instead says I'm going to draw a sample of a random handful of keys, and among those I'm going to choose the one with the least remaining time to live. For example, if your policy is time to live. So So in the same sense, if we were going to add a policy that said evict the largest keys, then it would presumably follow a similar pattern of select a small pool of keys, choose the largest of that selection to evict. And that's from the pieces of the Redis code that I'm familiar with, that would not be technically difficult to implement.
Right.
I think the machinery is all in place.
Okay.
So it would really be a policy decision.
Okay.
Yeah.
We have patched Redis in production in the past, but I don't think that's.
I'm not suggesting that as an immediate solution. The immediate solution is do something to get under max memory.
Yeah.
Because it seems like all of the other solutions, including cluster, are not going to fix things soon.
No.
They probably need to be done, but
looking at something here that I noticed is all of these view things. That's quite a large chunk. That's also a thing that I don't think is currently covered by our cross-slot validator, because I'm not sure, I need to look it up, but that's called in a completely different way. So that might be a good candidate to move to a separate instance.
Yeah, that's fantastic. Can you count digits there? It looks like that's one order of magnitude less than that looks like it's about 10% of the total key space.
Yes.
Okay. Fantastic.
I'm going to take a note of that. Matt, do you think we can do this like cold turkey? Just do we need to migrate the data?
That's a great question. So okay, so let's suspend let's pause the discussion about which keys we want to move and just move on to how do we move them.
Because which keys we can't answer yet, because we need to see where they're coming from and how they're used.
Yes. So I think that analysis is okay. So in terms of I want to take it back up a level. So in terms of next steps, the TTL analysis still feels like the shortest path. The next step, the immediate next step on that was, Bob, you were talking about rerunning the analysis to get like a finer grained distribution for at least the less than 1 day subset. That will be super fantastic, and I think that's probably going to let us. That will probably lead to some concrete recommendations about which keys. I guess what I'm thinking of is, if we imagine that we've got that data set right now, then we would be looking at we would essentially be evaluating the semantics of what harm does it do to reduce the TTL for each of the high frequency frequently occurring keys. And since this is a cache, it should be semantically safe. So I think it really comes down to the performance impact of earlier expiry.
Yes.
So I guess in that sense, we won't have numbers on this. I'm just kind of thinking out loud about how we would do that evaluation, pretending that we already have that distribution in front of us.
If we had the distribution in front of us, we would be able to see which keys can certainly live with a lower TTL because they have an idle time much larger than what we intend to set. And on the other hand, we can also like look where the batch of keys live. Like if most of the keys don't get accessed, like if we see that after an hour, there's a lot of space there. Like we have a lot of memory allocated that is older than hasn't been used since like an hour or 2, 3. Then that means we could lower the default TTL there.
Yeah,
does that make
that's
sense?
true. Yes. So if we haven't had a cache hit on that particular, if the mean time between cache hits. So all right, let me think about this. We're saying that if a key is if a cache key is relatively infrequently hit, then the cost of reducing its TTL is presumably lower.
Yes.
I guess another perspective on that is, and I don't know that we have any data on this, so it would really kind of be an ad hoc assessment. The whole point of doing the caching is to avoid extra work, and we don't have a good way to quantify how much work we're avoiding with these cache entries. So, for example, one particular kind of cache key is avoiding spending. I'm totally making this up. Say one cache key is avoiding spending. Say 100 milliseconds per key on the primary DB, and another type of cache key is avoiding the same thing on replica DBs. We have more replica DBs, so that's a less precious resource. So we'd prefer to preserve the cache key that's protecting us from consuming a scarcer resource.
Yes. Also duration, right? Like
yes.
But what I was more alluding to is like if we have here is idle time in days. But imagine these are hours. When you look at this, then I would be inclined to say like we can set the default TTL to 1 day, and we wouldn't really feel anything.
Yes, but it also wouldn't do very much good. I mean, we have to reduce the TTL of something below the point of its current retention.
Yes. But I'm imagining that like if we look at this bucket closer, like in more detail, then we're going to have a wider distribution at some point, which means we can say like if we put it there, we're going to lose 30% of memory, like up 30% of the memory, but we still have the 70%. Like we're actually
we want to preserve the cache hit rate too,
and then we need to know which keys we can do even lower.
So it was mentioned that like these are all caches, right? So caches as a whole are to preserve precious resources. Is there any, like, if we went and dropped the TTL to 30 minutes, would we be able to see what the impact is on the resources that we are caching from? Meaning, is there a really clear way to say, if we go and tweak these numbers, it's going to show a 20% increase on Postgres and a 20% increase on this, that, and whatever, other than cache hit rate, which is an
no.
Yeah, I don't think so.
I don't think that we actually count what a cache is like. We don't even know what a cache is covering in some cases. Like we know it in the code base, but not from here.
Yes,
from where
that's a great question, Stephanie. Actually, if you can find a way to concisely frame that, that's a wonderful question for potentially a future project, so that we can
and
the impact.
I'm noting this down.
Okay, awesome.
I've got to figure out how to put it in words, but yes.
Okay, yeah, no, that's absolutely fantastic. I love that, and that probably slots well to our team's kind of mission.
Yes, I think so.
Because theoretically, we should be able to know what happens if this is gone? Like, it's a cache. Theoretically, everything should still work if it's not there. Big on theory, I understand caching is complicated, but it doesn't seem like we had that information. So I will put that in works.
Yeah, no, you're right. We don't. I remember.
So,
yeah, go ahead.
I was gonna say, the other thing I mentioned was, does it make sense to try to vertically scale this? And please feel free to tell me, no, it's a dumb idea and we've already looked at it.
It's not a dumb idea. The challenge with it is, okay, there are a few challenges with it. The main obstacle is because we're beyond the saturation point, we don't know how much we would need to grow it to avoid that saturation. All we know is that the demand exceeds the capacity, which is why we're having these eviction bursts. It could be that if we add 5% more, if we raise the max memory limit by 5%, then we would top out at an additional 3%. I'm making these numbers up. I don't actually believe this is the case. If we added 50% to max memory, I would kind of call it a coin toss about whether that's enough to, level off, right?
So 50% would not be enough. I think we'd need to double it or something.
Yeah, like this is where like we don't have good data on it because we're already past that saturation point, and when we get below the saturation point, then we'll have numbers. But yeah.
So let me also step back and ask another dumb question. And I know we're totally out of time. But so I looked at what the current impact is on the cache, and we're definitely dropping.
I have to tack this. I just have to tack this on because it's so germane to what you were just asking. The inverse of that is how much do we need to reduce TTL to get underneath the max memory? And it's exactly the same class of problem. It's just easier to reduce the TTL than to grow the machines because that wipes the cache. So that's the logistics is the other aspect.
On the boxes that we currently have, how much memory? How much is max memory?
How much
below?
spare?
Yes.
Yeah. Let me go back and look at it. One of the tricky bits is, go ahead.
Yeah. Like that's easier. Like changing the configuration for max memory just while we're doing this to like buy some time until we do one of the bigger projects, which is a change to Redis or cluster or whatever.
Sure. Yeah.
And that's the kind of side effect of what I'm saying, which is I've looked at some of the things. It's clear that the AppDex for Redis cache is not good, but how big is the impact? Is this a thing that if we work on this for another month, everyone will be okay? Or is it a thing that if we don't have it fixed by next Friday, Rachel's going to cry? Because that's the other question.
That's a wonderful question. So first, Bob's question, just because it's quick, the host has 117 gigs of total memory. Some of that needs to be reserved for the file system cache. The other piece is when I need to double check this, but I think we have RDB backups disabled on this box. But when we lose a replica, that still kind of relies on the RDB mechanism. And I can't remember the details of that, but essentially the of whether that gets to use a special mode. But sorry, the relevant piece here is when we do, even with RDB backups disabled, at least when reprovisioning a failed replica, it still relies on the RDB mechanism, and that mechanism can consume potentially double the memory demand on the host, because the mechanism for it is to fork the main Redis server process and rely on the kernel's copy on write behavior to preserve that point in time snapshot of the entire memory footprint for the Redis process. And so the longer it takes to make that RDB, the more pages will diverge over time. And so for capacity planning purposes, we have to have enough. Yes, not necessarily a full double, but yeah, it's the theoretical upper bound is twice the memory demand. So it's a little hard to kind of plan in without knowing, for example, the lifespan that it would take to complete that. For the lifespan, the memory demand from the copyright mechanism for the entire lifespan of the process, whose virtual memory is forked from the main Redis process. Okay,
Yeah.
and then so that was.
So like we could increase it, but
Yes.
then we'd lose some resilience when we do need to do a failover, possibly, and
Yes.
rather not.
Yes, exactly. So I guess that means we could raise it a little bit, but not a lot.
And that probably, if we're running out of data in like the time period you said, 15-ish, 20 minutes, I don't think it's going to make
No.
like you're going to have to double the size of the boxes in order to get to a point where it might be useful.
Yeah, I think you're right. So Stephanie, you had a really interesting question and I've totally spaced down on it. Can you please repeat it?
Cool. I totally forgot what my question was too.
No, crap. Okay.
It was about what would happen if we lost the cache.
Oh yeah, that I already wrote down. Like what are we caching? What's impacted by a lower hit rate, and how do we quantify that with data?
Yes, and then the follow-up question to that was, what is the effect of the problem that we're seeing?
Correct. That was the other question, right? Is what is the effect and what is the time period? Because this seems to have been going on for quite some time. Yes. And the question is this a thing that we need to fix in a week, a month, a year, a day? None of the like.
Right.
I think we should have fixed it last year, but
yes, okay. Agreed. In terms
Yesterday.
of like our current mandate is so I guess the context here, Bob, please chime in here if I'm misrepresenting anything. We knew about this problem months ago, and it wasn't high enough priority to displace other planned work. This is more important now because essentially because we've been working, Bob in particular has been working with the stage groups, the feature teams to kind of own their error budget and work with them to improve visibility, and part of that kind of led to uncovering the impact of this on the feature categories that those stage groups own.
And those are things that users see. Those are client-side things. So
yes,
users are experiencing these slowdowns, and people have found that it was Redis. No, have pointed at Redis, and we started investigating, and that's how we discovered what this means. So the actual client-side impact is every 10 or so minutes, a whole bunch of requests take way longer than they should. And this is especially visible for groups like the people in the create stage who host like the Git endpoints, so the info refs and so on, like endpoints that are hit by Git clients, the endpoints that are hit by CI and so on, like the super busy ones. Those notice this the most.
Yeah, and in some cases it could lead to client-side timeouts, but mostly it's aptX regressions.
So my follow-up question to this is, I assume it's getting worse. Is that accurate? Like if it's growth related, I assume that at one point this was 20 minutes and now it's 10.
Or yeah, very good question.
Yeah, so it varies with time of day. So it varies with workload, which varies with time of day. My kind of anecdotal observation is it doesn't matter. You can look at there are graphs to show the pacing for it, but it will generally vary somewhere averaging about 10 minutes. I think we've seen it as high. Sorry, my recollection here doesn't matter. The graphs will show what the actual pacing is. Is it getting worse? That's the question.
Yes.
That's the question I was going to answer.
Is this like, do we see these spikes more often than we did 2 months ago?
So it's a little more. So as I recall, it was more severe in late last year, and then we had a lull, and that was probably because of the workload being reduced over the end of year holidays. And then in January it picked back up. There are a few factors that can drive it. I mean, essentially, from Redis's perspective, what drives this is how quickly the memory rises back to max memory after evictions clear out some headroom, which is the undesirable eviction burst behavior that we're trying to ameliorate. Factors that influence that growth rate, effectively the slope of the rise from back up to max memory, are feature changes where we store more things in cache, user behavior that happens to hit endpoints that that drive. I mean, changes to the cache keys can also drive this. So there definitely can be influence from application behavior and from end user behavior. We don't have a clear handle on that. But anecdotally, I've definitely seen the pacing of these of how often we reach max memory vary on a time scale of months, going both up and down. And I think that was mainly workload driven. And I recall also seeing a discrete change in behavior at least once where the frequency increased. And I think that was probably a feature change that did that, although I didn't track down which specific feature did it.
My thought on this was, if there's like a linear getting worse, which it doesn't sound like there is, which is great, that does mean that eventually there's a wall, at which point the world falls over. And that is a very clear, you have to fix it before this time. So
Right, yeah. As far as I know, we don't have a situation like that. This is a slow growth problem that we've just ignored for a few months.
Okay.
Fantastic question. Again.
Okay, so to conclude, what we're going to do is use less memory. We're going to do we're going
Yes.
to do that. We're going to do that by first of all seeing what TTLs we can just easily lower without any side effects to the application. It's also going to be hard to track down which keys that are, and so that might be a little bit a slow process. We're going to see if we can lower the
and we're specifically favoring reducing the TTL on keys that are that have a relatively high idle time. So those
high
are
idle time, big keys is what we're looking for.
Yes, exactly.
That means for that we need another type of analysis, like we need the memory analysis, but for idle time, which is I'm going to figure that out. And then
for that, go ahead. Yeah.
So for that we need to. What were you going to say, Matt? Maybe you already know how to do it.
No. I was just I was thinking about since we're interested in 2 dimensions of the data, I find it really helpful to frame what I want the output to look like before doing the implementation work. So that's all I was going to say.
If you have an idea on how you want the output to look, then please comment it on the issue, because I don't yet.
Yes, I don't either. I want to take a.
I just spit stuff into tables if I don't know what I want to look at, and then look at some data to know what and then see.
Yeah, no, totally. I was thinking I wanted to spend a little more time looking at the data that you've already put together, and maybe mock what I guess I want to sketch what ideally I would like to I'd like to extract from that, in terms of the subdividing the existing categories. So that's it.
So we look for high idle time keys, then we see how to reduce the TTL on those. We're also going to have an overall, do the investigation of that first day. If there's an overall thing we spot, like if we can reduce the overall TTL by X days, and see how much we'd gain doing that, because that's a simple solution. But then we need to see what the idle time, what the what the impact would be to the hit rate, the cache hit rate.
Yes. For point 7a2, where we said look for high idle time and big keys, I think maybe I'd refine that to be rather than big keys, it's a large.
Overall.
Yeah, exactly.
Because
It doesn't
we
matter
can
how big
have,
the
if
individual keys are. It's
one
the
of the keys
total.
that is in there, for example, is the exists cache. That's a boolean. It's a 1 or a 0 stored there.
Yeah. We
I
spend
went
more
with
space on the name of the key than the actual value.
Yeah.
large key namespaces.
Yes. Good.
Is that?
That. Yes.
I
Sure.
understand what you're trying to say. I just don't know how to put
Yeah.
it into English because that's the only language that I speak. So
Sure.
And then
I'm just bad at it.
for the very future, we need to figure out, but maybe that's something for our counterparts in the frameworks team to do. We need to get some consistent naming in cache keys, because
Yes.
if all the significant identifying bits were in the beginning of the cache key, like to see where a cache key is coming from, and then the identifiers like project ID and user ID were at the end, then this analysis would be so much easier. But yeah.
I feel like that's a wish list item that's never going to happen.
Never
But it's
going
nice
to-
to talk about.
Yes. I felt like I just needed to mention it at least once somewhere.
Yes.
I've got it
yes.
out. I've got it out. Now it's fine. Okay, cool.
Okay, and then in addition to that, once we've selected some keys that have a high idle time and collectively represent a large amount of storage, we should spot check that to the kind of assess to the best of our knowledge if any, before reducing their TTL, if any of them are known to the three of us at least to be particularly expensive, and maybe skip them. I don't have a good idea about how we would empirically test for this. So at this point, I'm just thinking, we take a look at what we we take a look at the code path that populates that key value, and if it's if it's obviously expensive, then we kind of do a further assessment.
I've also noticed that we store a lot of duplicate data in the cache, like rendered commit stuff that we need to render differently for certain users, but most of it's the same. It's just we copy everything and then do it for each user. So yeah, there might be things that we need to optimize there, but I wonder if doing optimizations like that is going to take a bit too long.
Yeah, that's essentially kind of deduplication as maybe kind of a side project.
Yeah.
Or opportunistically looking for for duplication that we could remove.
Well, it's hard to spot. Now I looked into a few of those big keys and that's how I spotted it, but
right, okay.
You can't just get it from data. You can't just see it.
No. Yeah, like if we had a point in time snapshot like an RDB backup, then we could. I mean, most of the time we're looking at the names of the keys, but we could also look at do an assessment of looking for duplicate values across the whole database, and then identify what names those keys had.
I've thought it would be handy to have like an RDB dump of the whole Redis instance, but the problem is that as soon as you load it up, the TTLs have passed.
Right,
So,
we'd have to do a static analysis of the data without.
So you basically need to dump the entire thing into another format or the same format, but that doesn't. Yeah.
Enforce TTLs.
Yes.
Yeah, totally. Oh gosh, that would be a fabulous Redis feature of ignore TTLs, for diagnostic purposes.
Yeah.
Yeah. I guess a really dumb way to work around that would be to, sorry, this is a total tangent. We could basically run a hacked Redis binary that just ignored TTLs.
Could you also are the TTLs based on system time?
No, they're
crap. That would have been
countdowns if I remember, like just UTC.
Yeah.
Seconds.
So my method of just change the date on the host does not work. Got it.
Actually,
maybe it would actually.
Yeah, now that I think
they're
about
stored
it,
as epoch timestamps.
Yeah, epoch timestamps. I think so.
Yeah.
So yeah.
So maybe.
Okay. To stop the recording.
So
Uh,
oh, you can stop the recording.